right, we are continuing section 3.3 today, solving quadratics with complex solutions. And today we are focusing on finding the number of solutions, whether they are real or non-real. And we're also looking at how to use the quadratic formula in order to solve quadratics. So first we'll look at finding the number of solutions. And this is when we have a quadratic that's written in the form of ax squared plus bx plus c. So that's kind of like our standard form for our quadratic. And remember our quadratic formula from Algebra 1. That is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So these are two important things that you need to remember for our lesson today. We're going to be using both of them quite frequently. Okay, so the part, if you notice in our quadratic formula, the part that's under the radical has a special term. We call that the discriminant. So b squared minus 4ac is called the discriminant. And what the discriminant tells us is the number and type of solutions we have given a quadratic equation or given a quadratic function. So what this does is it determines the number of solutions. Okay, so for example, if we have, if we're solving our quadratic or using our quadratic formula to solve, and we substitute all our values in here, and we get to the point where we're ready to simplify this part under the radical or the discriminant, we know that if this value, so b squared minus 4ac, if this is greater than 0, then we know that there's going to be two possible answers, right? That's like if we take the square root of anything that's besides 0, that's a positive number, we know it's going to have a positive root and it's also going to have a negative root. So this tells us there are two real solutions, so not the complex or imaginary kind. So they are real numbers, real solutions. Now let's say we have our discriminant that equals 0. So we know that if the part under the radical is equal to 0, then when we take the square root of it, it's also just going to equal 0, which yields just one real solution. One real solution. Now in Algebra 1, if we had a negative discriminant, we would stop right there and we'd say, oh, sorry, no solution. However, now that we have imaginary numbers, we know that what this really means is that we're taking a square root of a negative number, which is going to yield imaginary or complex solutions. So we can say there are going to be two non-real solutions, whether they are imaginary or complex. Remember, imaginary numbers have just the I. A complex number has the imaginary part plus a real number added to it. So it could be either one. So now let's go ahead and look at how can we tell whether or not, or like what kind of solutions we actually have. So let's look at an example of using our discriminant. So I have an example here from our textbook, and this is on page 143. And what we are asked to do is to answer the question by writing an equation and determining if the solutions are real or non-real. So we have to do two things. We have to write an equation, and we have to determine if the solutions are real or non-real. So whenever you are asked to determine whether the solutions are real or non-real, that is your hint to use the discriminant. So let's look at our problem. We have a hobbyist is making a toy sailboat. For the triangular sail, she wants the height h in inches to be twice the length of the base b in inches. And she's trying to decide, can the area of the sailboat be 10 inches squared? So she said the height needs to be twice the base. And we know that if we're finding the area of a triangle, we say that that is equal to 1/2 base times height. So what we'll do is we'll go ahead and substitute our h with 2b. So h is 2b. And we know that those 2's will cancel out and we're left with area equals b squared. So what we need to do now is try to decide, can we actually have this area of 10 square inches? So we're going to plug in 10 square inches into our area. I'll write that up here. And we know that when we're using the discriminant, we need to make sure we are in our standard form of our quadratic. So we have ax squared plus bx plus c equals 0. And what I'll do is, since we have a b here and a b here, I'm just going to rewrite this in terms of x, just so we don't get confused. Okay, so we have 10 equals x squared, and I need to rewrite it in terms of, or in my standard form. So I'm going to go ahead and subtract 10 from both sides. And our equation is 0 equals x squared minus 10. So if I look at my equation, I look at my standard form, I can see that a will equal 1. That b, there's no b term, there's no middle term, so b equals 0. And c will equal negative 10. So now in order to use my discriminant, I just have to plug in a, b, and c into b squared minus 4ac. And see what I get. See if I get something greater than 0, something equal to 0, or something less than 0. So b is 0, so 0 squared minus 4 times a, which is 1, times c, which is negative 10. And all of this will simplify to 40. So I get something that is greater than 0, which means I have 2 real solutions. So what does that mean in the context of my problem? Their question is, can the area be a sail? Can the area of the sail be 10 square inches? And the answer would be yes. We know there are 2 possible solutions, and they could potentially be the same, but we know that it is most certainly possible. So we can say yes, the area can be 10 inches squared. So now we're going to look at how we can use the quadratic formula to solve a quadratic. So our example will be to solve negative 5x squared minus 2x minus 8 equals 0. And remember, our quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And this works when we are when our quadratic is written in standard form, which is ax squared plus bx plus c equals 0. So the first thing we have to check on to make sure it is written in standard form, and we see that it's written in descending order and the right-hand side equals 0, so it is good to go. What we want to do next is identify what is A, what is B, and what is C, so that we know what values we are plugging into the quadratic formula. So A will be negative 5, B will be negative 2, and C will be negative 8. So all we have to do is substitute those values in and then evaluate. So x equals negative b, so negative b, which is negative 2, plus or minus the square root of b squared, so that's negative 2 squared, minus 4 times a, which is negative 5, times c, which is negative 8, all over 2a. Okay, so now from here we just have to simplify. So we're going to solve the part underneath our radical, and then we'll slowly work our way to the outside of a radical. So we know negative 2 squared is 4, and then we have 3 negatives in a row. So a negative times a negative is a positive, times another negative is a negative. So we have negative 160. 20 times 8 is 160. Bring down our plus or minus, and we have a negative, negative 2. So that's going to turn to a positive 2, and then it's all over negative 10. So now we can keep simplifying underneath our radical. So 4 minus 160 is negative 156. And from here, we need to simplify our radical. So we can see, and I'm going to go ahead and do that off to the side because there's a lot going on over here already. So negative 156, we know we can split it, first of all, into the negative. times 156. And from there, we know 156, we want to pull out a perfect square. So 156 is 4 times 39. I'll bring down my -1 here. Make these arrows so they don't look like ones. Okay, and now we can actually simplify. So we know the square root of -1 gets us I. We know the square root of 4 is 2. And the square root of 39, there's nothing we can do here because the two, or I guess all of the factors that are left are not perfect squares, so it can no longer be simplified. So we go ahead and just multiply whatever's in front of our radical. So in this case, it'll simplify to 2i times 39. So I'm going to go ahead and put that back up here and replace my square root of -156 with 2i root 39. And I keep my plus or minus. Okay. And now what I do is I want to see if I can simplify anything further. So I notice that I have some even values here. So we have 3 things with an even factor. So we can go ahead and divide by 2 to this term and to this term and to my denominator. So remember, if I am dividing, I have to take it out of every term if I'm going to take it out of my denominator. So we'll go ahead and say 2 divided by 2 is 1, plus or minus. So we took out the 2 here, we divided it as well. So it's I root 39. And then I also divided the denominator by 2. Okay, so typically this is our answer, but it's not written in a form that we would usually see. Typically, we like to have this negative out in front, just so this is kind of the proper way to write it. We can say it's -1 plus or minus I root 39 over 5. And this would be our solution to our quadratic equation that we solved above. So we can tell that this is definitely a non-real solution. We have an imaginary part and we have the real part. So this would definitely be a complex solution.